What I discussed today was how different xylanases can affect the application, specifically looking at the feed application. I started off by showing how the xylanases are from different families. The different families mean they have different structures. That in turn means that they have different properties. But even within a family, you can have a huge amount of variability in terms of temperature optimum, pH optimum, sensitivity towards inhibitors, for example. So when we say xylanase, that itself doesn't really mean very much. We need to be much more specific about what xylanase we're talking about, what its specificity is, what substrates we're talking about. And in fact, if you look at the commercial xylanases available, they are all sorts. They have high pH optimum, low pH optimum, they are temperature sensitive, temperature stable. But I think the take-home message is there are lots of different xylanases. Their properties matter.
The session today started by just identifying the fact that when we say the word xylanase, it's not like vitamin A. There's only one vitamin A. When we say xylanases, there are many xylanases, completely different characteristics. And when you look at them and the way they work in the animal, the way we assay them, the way we're able to assay them, and how they survive, not just pelleting of the diets that we make for our animals, not only just surviving through the intestinal tract, they all differ in their abilities to survive these processes and these rigors. And as a result, it's unlikely that they'll all deliver the same response in the animal.
Know your process, or in this case, know your animals and know your enzymes. Everything follows from that. If you know your process, if you know the animal, then you know what you need to do.
And then it's my belief, I left this a long time ago, that we need to know much more about these materials that we are working with to really understand. You can add enzymes in two ways. One is trial and errors. You produce a lot of enzyme and see what's happened, and you end up, as my previous speaker showed you, sometimes it works, sometimes it doesn't work. The other way is, of course, to know exactly what type of enzyme you have and exactly what type of substrate, as much as you know. Then you can do much more precise, I think, studies for the future.
Most important thing is to understand or to define the mechanism of action. And a better understanding on this part would, of course, would increase the penetration or acceptance of the concept by the feed industry.
One of the main drivers of the market in the future is new product development, and we've discussed a lot of elements of that during the conference. We built our flagship product, Echinase XT. We designed it around thermostability, assayability, and in vivo efficacy, so how it works in the chicken.